Let's talk a little bit about arrays in this video. So depending on the programming language that you learn as your first programming language before to come to this class, you already know most of what I am about to tell you about arrays, or you are going to discover arrays as something a little bit more restrictive. People in the first category generally have studied Java before to come here. People in the second category have studied Python. So what I mean by that is that in Python, let's start by this one, you generally learn to use lists, right? And lists are so convenient. You can add element very easily. You can retrieve element from inside the list and so on and so forth. You have this slicing operator that is very, very convenient. Well, what we're going to look at in C is more like a base implementation of the concept of array. But the good news is that the logic, the concept is really very close. It's really the same, actually. Let me take something to write real quick. Here we go, a blank page. So what we're talking about here is we're talking about having variables. So I'm going to call mine data, okay? And instead of having, well, let's start with a variable, like an int variable int data, okay? So when I have an int data equal 23, what I have in memory is a variable, and here's the storage for the variable with the number 23 inside of it, okay? And when I have an array, int many, so I should have used that datum and data actually. If I have an int many and I declare this as an array of 3 elements, okay, what I end up with is a variable many with 3 storage location for numbers like 23, 42, 99. Okay, whatever I want. These are going to be int numbers. And inside this array, I use indexes, so small numbers, right? Small positive numbers, to say this is the index 0 element is 23, the index 1 element is 42, the index 2 element is 99. Okay, and I access the variables inside the array, the slots inside the arrays, using this indexing notation. So why do we even need to bother with this? So this might be like a refresher review from your first introduction to programming, okay? But if I have, for example, a program where I declare int data, I tell the user enter a value, there we go, and then scanf a %d, which is an int. By the way, I'm going to use ints a lot and arrays of ints a lot in this video, but everything that I'm telling you about an array of int is true about an array of, for example, double. So if I wanted to change the data type of the element of my array from int to double, the same rules would apply. So here in this example, I don't even have an array yet. I have just a variable data, right? So I do a scanf %d and %data. And then I'm going to say printf the values that you entered. So I'm making values plural because we are going to have many very soon. Are, all right, and printf data is %d. I'm going to go to the next line and I'm going to display the content of data. Okay, so nothing new right now. I'm just using a simple int variable data. I'm going to compile this program. Here we are. I'm going to run it, enter a value 23. The values that you entered are data is 23. Main function done. Very good. So what if suddenly I'm asked to write a piece of code that doesn't read just one piece of data like that, but two, and process it, do something with it, or just displays it back in the screen? Easy. I'm going to declare int data1, data2. So I use a comma syntax here because the two variables are of the same data type. So I declare them all in one line. And then when it comes time to read the data, I'm just going to do cut and paste oriented programming. And I'm going to store the value, the first value I read in data1, the second value in data2. And same thing here, when it comes time to actually display on the screen the values that are read from the user, I'm going to printf data1 is something, data2 is something, and of course, I'm going to display each time the variables. Nothing really exciting here, nothing really new. Okay, I compile this, a.out, first value is 23, second value is 42. The values that you entered are 23 and 42. And then I need to do that for 4 values. Okay, I can do that. A lot more cut and paste, right? And then I need to do it for 16 values, 24 values, 50 values, 100 values, maybe 1,000 values. What about 10,000 values? I can still do it, but I would be crazy to do it this way. Okay, so the more value I have, the more variables I'm going to have to declare here, the more times I'm going to have to cut and paste those lines of code and this line of code here as well. I need a loop. If you tell me, I want n variable values to be entered by the user, which is the next step, right? First I want 1, then I want 2, then I want an arbitrary large number, then I want n arbitrary, okay? Then I want to do a loop. And what if that n is not even known at compilation time? Okay, what if you tell me I don't want you to write a program that's going to read exactly n values? I want you to start by asking the user, how many values do you want me to read? And the user is going to type a number, and that's your number. That's how many values of type int you need to read and then display back to the user. This is impossible to do without arrays. So let's start with basic arrays in C and replace this by actually an array named data. So how do you declare arrays? Like so. Int, the data type of the element that you want to store in the array, the name of the array, followed by square bracket. And between the square bracket, the brackets, plural, this is where you are going to specify the size of the array. That is the number of elements you want your array to be able to hold. So if you tell me, for example, you're going to read 2 values from the user, okay, there you go. I have an array of size 2. How do I access one element in that array? I use the name of the array, and then between square bracket, I use the index of the element. And the only thing really that's tricky here is you have to remember that arrays are indexed starting with the index 0. So the first element is at index 0. The second element is at index 1. So if I tell you you have 2 elements in your array, the last valid index in the array is 1, 2 minus 1. Okay? If I tell you you have 5 elements in an array, then the last valid index is 4. Okay? And I cannot do it like that, so I'm going to do it with a thumb. 4. There we go. So it's always like whatever the size of your array is minus 1 tells you the index of the last element in your array. And you start at 0. Okay, so 0, 1, 2, 3, 4. Here's my array of 5 elements. So now that I have done this, and you see that I use data index 0 and data index 1, I use them exactly the same way that I was using an int variable. Well, that's what an array is, right? An array is a variable that contains inside of it multiple slots. So it's like if it contains multiple variables, right? And in C, all those variables have the same type, data type, and all of them are stored in memory contiguously, one after the other. This is what allows me to access them with a simple index number, okay? We're going to talk more about that when we do pointers. But for now, these are the basic rules for a basic array in C, and I can use this notation, data index 0, data index 1 here to access the first and second element anytime I was accessing before my variable data 1 and my variable data 2. Okay? Well, let's make sure that this is working. Let's save. GCC, a.out, first value 23, second value 42. These are the values that you entered. And now this program scales up. You want me to read 4 values? No problem. I'm going to put a 4 here. But wait a minute, I'm still doing the code here, unrolling the code by hand. You're right. So this is not the smartest way to do it. So let's try to do this job a little smarter as we switch to 4 as a size. So I want to use loops. So I want to use a loop here that's going to allow me to say enter a value and read that value many times. So let's use, for example, do while loop. Do. There we go. While, and I'm going to come back to my condition very soon. Okay. I have here a size of 4. Okay. So I'm going to declare size t, that's the name of a new data type, okay? And I'm going to declare a variable named size. And the data type size t is used anytime we measure something like the size of an object in memory in C, or whenever we iterate over the element of an array, okay? This is pretty much an unsigned, so that means always positive, integral value. So typically an int, okay? But this is actually the standard is every time you iterate and you use indexes over an array, use the data type size t, every time you measure the size of something in memory in C, use the data type size t. So I'm going to say the size is 4. And here, I'm going to use this variable size. So this is something that was not possible originally in C. If you do your reading assignment, and I really hope you do, because this is an important part of your learning, right? When you do your reading assignment, you are going to see that basically when you define an array in C, normally what is in between the square bracket is something that needs to be known at compilation time, like the value 4. Okay, a variable multiplied by something, maybe a variable that you read from the user, which is going to be our next step. All of these originally didn't work in C. Now they introduce variable size arrays, and I'm trying to remember which, I think it was C99 that introduced those. So they have, for a little while now, introduced the concept of variable size array, which allows you to specify an expression here that's going to be resolved at runtime, that's going to be known at runtime. So you don't need to just put constants and numbers here like before. You can put variable names, and like we're going to show very soon, you can even read those variable names from the user. So here I'm declaring an array of size, whatever value is in the variable size, okay? And I'm going to have an index. So I'm going to say size t index. I'm going to start this index at 0. I'm going to use the index to access all the elements in my array one after the other. At the end of the iteration, I'm going to increment index, and I'm going to keep doing that while index is lesser than size. So I use lesser strict, okay, not lesser equal to size, because if the size is 4, remember, then the indexes are going to be 0, 1, 2, 3. Okay, so I stop at 3, 4 minus 1. So here I want to stop right before the size of 4. And so I'm going to do a loop like that to read the data, and then I'm going to do a loop here as well. So I'm going to reset my index to 0, and then I'm going to say again I'm going to use only one of the printf, index plus plus, while index is lesser than size. And I would have to write this a little differently if I was accepting, size being equal to 0, but I'm not going to. I'm going to at least have size minimum 1, and then the program is going to work with those loops just fine. Here data index 0 because data index the value inside the index variable, and we should be good to go. Let's save this. Let's fix typos and then test it out to see if it works. So expected while at end of input, I forgot to close something. Yes, I forgot to close the curly brace here. There we go. All right. Compile again. Run it. So 4 values, right? So I'm going to do 1001, 1002, 1003, 1004. The values that you entered are 1001, 1002, 1003, 1004. So it is working. And now we can scale this to whatever we want. Okay. And because of variable length arrays in C, this semi-recent evolution of the C language, right? It was more like catching up with more modern language, actually. We can have here something that's going to be known only at runtime. So we could even do something like that. Printf, how many values do you want to read? All right. And then I'm going to do a scanf, and I'm going to say I want to read. So for size, the format specifier when you display is ZU. So we are going to use the same one to read and see if this is correct. Otherwise, I'm going to pause the video and look it up real quick. Person ZU. So that captures the fact that it's a value that is unsigned. Okay. And we are going to read whatever the user type into the variable size. Okay. And then we're going to define our array using that size. Let's start with just testing that, okay? Because I'm not 100% sure about that ZU. So we're going to go gcc main.c, a.out. How many values do you want to read? Well, I'm going to go with 3. 1, 2, 3. The values that you entered are data 1 is 1, data 1 is 2, data 1 is 3. Interesting. Well, that's going to lead us segue into our next topic. What if I don't want to display always data 1 here because it's kind of stupid, right? I've totally overlooked this. So what I want to display instead is data index, and I don't want just a 1 to be here always. I want to display here. I'm going to use ZU again because I'm going to display the index. I'm going to display the value of the index and then the value of my element. Okay? So here we are. We have a printf data index %ZU is %D. Go to the next line. Let's try this out. So going back here, GCC, run it. How many values do you want to read? 4. Enter your first value. 4, 8, 16, 32. Alright, 4, 8, 16, 32. And this time is displaying data index 0 is 4, data index 1 is 8, data index 2 is 16, data index 3 is 32. Okay, so we have here finally a program that is going to read n values, whatever the value of n is, from the user, and the user can even specify those values at runtime, and is going to display them. So we have pretty much defined a one-dimensional array of elements, each of data type int. We could have done that with doubles. We could have done that with even like anything, char, etc. Any of the pretty much data types that you have learned so far to use in the C programming language could be used here instead of int, and that will give us an array of elements that are each of that specific data type. So watch out for that, okay? This is one of the differences with, actually there are many differences with list in Python, for example. The first difference, the size is fixed. The second difference, all the elements in the array at the same time. In Python, the size doesn't have to be fixed. Okay, that means that when you decide here to define int data square bracket size, your array can at maximum accommodate size element, whatever the value of size is. Okay, if later you want to add more elements, you can't. That's not something that happens in Python, right? The other thing that doesn't happen in Python is in Python you can put in list, you can put an int followed by a floating point number, followed by another integer, followed by 2 floating point number, followed by a character, followed by a string, maybe followed by the data type of each element can be whatever you want for each element independently. In C, just like in Java, when you declare a basic array like this, not only the size is going to be fixed once you are done defining the array, okay, but in addition to that, you are not going to be able to put what you want in the array. You are going to have to be able to put only elements that all share the data type that you specified right here, data type int. Okay, so I hope you see the similarities and differences with the arrays that you have learned to love, in your previous introduction to programming. So here we are like a very basic version, pretty much, of those arrays. Okay. What else? We are going to, so we learned to define a one-dimensional array of any primitive data type, pretty much, just replace it by whatever you want. We have initialized it, but we have initialized it by reading stuff from the user. Okay, so that's fine. I could also have put a loop here, so let me comment this out. Okay. So I don't want anymore to read stuff from the user. I want to do a for loop, for example, that's going to say for size t index I equals 0, I lesser than size I plus plus. Okay, so I really mimic what I had in the do while loop here. And what I'm going to do is I'm going to assign to data index variable I. Okay, I'm going to assign a value. And that value is going to be, for example, well, we wanted to do what, 4, 8, 16, 32. So 4 to the power, so I'm not going to do to the power because I need to use the math library for that. It's not worth it. I'm going to say int value equal 4, so that's going to be my starting value, okay? And here I'm going to say data equal value, and then value is equal to value multiplied by 2. I use a shortcut notation, shorthand notation here. Instead of writing value equal value times 2, I wrote value times equal 2, which is exactly the same thing, okay? Same as value equal value times 2. All right. I just use that one just to get you used to those shortcut notation. Okay, they are not essential, but you need to be able to not be surprised if you read them in somebody else's code that you downloaded or that you are reading on a Stack Exchange, for example, to try to understand something. So I'm assigning value to all of those elements every time I multiply. So that should give us 4, 8, 16, 32 as well, but this time I don't have to enter the values myself. I'm going to compile. Ah, I forgot something. Did I use index again when I should not have? Let me see. Index equals 0. Oh no, I forgot that if I commented it up there, then I had to declare it. I mean, to declare it for the first time down here. So let's go back. GCC main.c, a.out. How many values do you want to read? Oh, it's still asking me. Well, I'm going to do 5 values this time. So 4, 8, 16, 32, 64. So I don't have to type them. It's not reading them anymore, but it's iterating that many times. It's defining an array of size 5, then iterating 5 times, filling in the value that we have in the variable value, then multiplying this value by 2, and then iterating again over the whole array and displaying all of the values inside the array. So we can initialize by reading from the user. We can initialize by actually having a loop and constructing the values and assigning them one by one to the element of the array. There is another possibility to initialize an array in C. It's a special notation that uses an initializer list. Okay, so I'm going to comment out the line where I declare data. I'm going to actually stop asking, how many elements do you want? I'm going to fix that again for this example. For this example, I need the size of the array to be fixed. You're going to see why, okay? What I want to do is I want to say I want an array data of size, let's say 4, and I want it to contain, and I'm using the curly brace notation here in a different way than what we have been using it for until now. It's not a block of code, it's going to be a block of data. So I want to say that my array should contain the value 4 as the first element at index 0, followed by, so comma, followed by 8, followed by 16, followed by 32. Okay? So I define here an array of int elements. How many of those elements do I want? I want 4 of them. What values do I want to preload the array with? The value 4, 8, 16, 32. And I don't even have to do this loop here. I just specify the values here, separated by comma. So because I write the list, the extensive list of all the values separated by comma here, that means that this size here needs to match first. And second, this size should be known at compilation time, okay? If I ask the user, how many do you want to read? And the user tells me 16, well, I didn't know what numbers the user was going to tell me, so I could not have anticipated, what I had to write here. So now that I'm writing directly in the code what I want to initialize my array with, then it follows that the size of the array is going to be known during compilation of the program, okay? And you can even do something, since you specify here the elements between curly braces, you can omit the size here, and the compiler is going to just be smart enough to figure out that you have 4 elements here, so the size should be 4. So it's optional, it's completely entirely up to you. Let's compile this, let's run it. 4, 8, 16, 32. Again, this is working. Okay. So the last thing I'm going to discuss really quick is, so let's say that I'm going to resurrect, meaning uncomment. I'm going to uncomment this loop here, bring it back to life, and I'm going to say size t size equal 4. Okay, that's the size that I'm using right now for my array. And or I could, since it's none at runtime, I could put a 4 here, here, and so on and so forth, right? It's better to have a named variable like that, especially a named variable defined of size t. That's kind of like a big target sign on the variable that say, hey, look, it's a variable of type size t. It's probably used as an index in an array or to measure the size of something in memory. Okay, so it's a good idea to have a variable like that to represent the size of your array instead of hard coding the values in the code itself. Okay, and to change things a little bit, I'm going to override my initialization, but this time start with the number 8. Okay, my loop int I lesser than size, perfect. But what I want to do now is I'm going to display the content of my array, and instead of displaying every element, I'm going to display only one element over 2. So I'm going to skip one element every time. All this to show you that, yes, I can initialize here and I can follow, every element one at a time using this loop, but then I can make another loop that's going to iterate differently over the array. I have complete control here on what's going on, right? Including apparently introducing typos. So redefinition of size, I had size defined already. Oh yes, I had it defined at the top. I didn't need to. I thought I commented out. Okay, I didn't need to type it here. So let's go and fix that before we go anywhere else. So what I was saying is that you have control here on how you want to iterate over your array, right? So I iterate so that I consider every element. That's the loop that's going to add 8 as the first element, then 16, then 32, then 64, and so on and so forth. And then the second loop here is deciding that, well, you know what? I don't want to display every element. I'm going to display the first element, and then I'm going to increment the index plus 2. So the first element is at index 0, then I go index 2, and then next time I'll try to go index 4, but index 4 is going to be past the end of the array, right? Remember, array of size 4, the index is 0, 1, 2, 3 only, okay? So when I compute my index here and it reaches the value 4, I'm out of the array. That condition here is going to cause me to leave my loop and stop executing the loop and then display when function is done and exit with a success error code. Okay, so we covered pretty much the basic stuff on pretty much basic C arrays. So it's a lot less evolved, a lot less user-friendly maybe than what you've learned in Python and the list that can change size automatically. If you come from Java, this is pretty similar to basic Java array, especially that now since the revision in, I think it was 99, since that now we can specify here expression between the square bracket when you declare your array that are known only at runtime, okay, that as a result of multiplying a variable by something that you read from the user, blah, 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 whatever you can imagine, okay. So this is very similar to what we do in Java, but Java has also the concept of array list, that again, if you studied Java as a first language, you probably covered, and array list allow you actually to do pretty much what's done in Python with list, with a few minor differences that I'm not going to cover in this video. So here we have pretty much the ancestor of all of those solutions, right? This language is much older than Python and Java put together. We have the ancestor of the solution, very basic toolkit on how to create arrays of data, manipulate them, so define them, manipulate them, and then iterate over them. All right, and we're going to wrap it up here for this video. As usual, if you have questions, come see us in office hours. Don't hesitate to post in forum, Piazza, whatever we're using this semester, right? And I'll see you in the next video.